Welcome, everyone. Thanks so much for joining us. My name is Lukáš Rikaučan, and I'm a researcher, theorist. I work mainly in the field of political ecology and philosophy of technology. But today I'm here mainly in a capacity of a facilitator of a debate that we're going to have today, debate based also on two talks by our dear guests of this second event from the Architectures of Nature series, which is curated by Viper Gallery in Prague, in Czech Republic. And I'm gonna also present you the guests in due course. But first of all, let me tell you a bit about a concept of this event, because this event, Architectures of Nature, is based on an idea that we can trace different basic elements or say different basic fundamentals of a different approach to the architecture, which would be based on following or imitating certain natural realities. And this particular event is tracing the element of water. And it also departs from certain utopian vision, let's say, also in Soviet architecture, for example, where there was in 1960s this group of young architects, which was called NER, Novyi Element Rasseleniia in Russian. And this group of young architects came up with an idea to think about the city as a kind of river. And their vision was extremely infrastructural and also extremely metabolic. And it hinted towards some kind of different future of the city, one that obeys the logic of dynamic flows instead of that of static structures. And that is just one of the many templates for reimagining architecture and urbanism around the second element of the Architectures of Nature, because this is the second event of the Architectures of Nature series, and that's the element of the water. In the conversation we're going to have today, we will be joined by two specialists whose expertise in designing urban environments is intimately linked to rivers, to seas, to floods, and to other modalities of water. And aside of examples of how the element of water dramatically shapes and intervenes into the fabric of the cities around the world, we will also touch upon more speculative exercises on how water can shape policies, how water can shape governance, and how water can also shape territorial jurisdictions. So our two participants today are Nabi Agzamov and Nashin Mahtani. Nabi is urban resilience specialist at Strelka KB in Moscow. He is trained as an architect and urban designer, and he works on creating a more sustainable and resilient environment by strengthening the relationship between water, ecology, and cities. In 2019, Nabi worked on speculative design project MERA, which redefined the territory of Caspian Sea based on the primary logic of watersheds, the dynamic relations they offer and require, and the cascading flows of resources they shape. He worked at an urban design and landscape architecture company, Scape, in New York, and he co-designed the Ecological Citizens exhibition for the US Pavilion at the Venice Biennial of Architecture in 2018. And Nashin Mahtani, our second guest tonight, is an architectural theorist and designer, which investigates the interplay of software aesthetics, ecological governance, and social behaviors to advocate for environmental justice. She is the director of Peta Bencana ID, which is the disaster map of Indonesia, where she leads a multidisciplinary design research team in developing humanitarian infrastructures for climate adaptation. Nashin is also co-investigator of MERA, a research collective which develops speculative proposals for new sovereign layers of governance based on ecological systems. Her work spans from activism to design and scholarship, bridging the disciplines of architecture, infrastructure, politics, humanitarianism, and design activism. And as I was talking about Nashin Mahtani now, I will also invite her to share her screen and to start her talk. Thanks so much, everyone, for joining us again.
Okay, can you see my screen?
Yes.
Thank you. Lukash, for the introduction. It's really great to be able to share some work from both of our practices, as well as points at which they converge, as we think together through water as a connecting rather than a separating force to design with. And so I'll start by sharing a little bit about the work that this collective we, have been working on in Indonesia, where we build softwares to support climate change adaptation, and how software can begin to act as infrastructure, not only for humanitarian efforts, but also to reframe urban and ecological relationships. And so to provide a little bit of context, I will start by introducing Jakarta. This is a city as it is seen from the northern coast today, and our project started in Jakarta. But Jakarta was originally a swampland, and so the seasonal monsoon was always part of life. But since the 17th century, when it was colonized by the Dutch, water entering the city became framed as a problem because it was disrupting economic activities and European concepts of linear progress. And so since then, the dominant approach to flooding has been to build large-scale infrastructures to separate water from the city, to relegate its flow to where we imagine it should remain. And yet, despite these efforts and increasingly larger infrastructures, they all remain susceptible to the pressures of the biosphere. The major flood disasters in recent years have been a result of infrastructure failure. Because with climate change, what we're experiencing is not a greater volume of water, but a greater intensity of water. And the infrastructures we have in place can't keep up with the pace with the increasing intensity of the climate. And what I want to emphasize here is that first, no matter how much computation we have, we cannot accurately predict the impacts of extreme events. And then related to this, no matter how much concrete we pour, it cannot always ensure the separation or containment of water in the city. And so accepting that extreme weather will happen, that water will enter the city, and at times when we don't expect, how can we think of different practices of living with the monsoon? Well, people living most closely with a particular set of challenges often have very useful ideas about how to deal with them. And although in Jakarta we can no longer predict the arrival of the flood, digital media networks have provided new channels through which residents can self-organize in real time in response to the water's flow. And so even during the flood, as we see in this image here, Indonesians love sharing information on social media, and they're actively sharing information about points of access, infrastructure updates, and community response. In 2013, when the project started, we saw that there were over 150,000 geotagged tweets about flooding in a period of 6 months. And in this image, the black outline is the administrative boundary of Jakarta, and each blue dot represents a tweet about flooding. And so we see that the tweets are coming from basically the entire city. And what I first want to suggest to you here is that what you're looking at is the image of the river as it has gone through a process of mediation. Because as the river overflows its banks, the excess of water is captured in the form of posts, tweets, and messages. And so recognizing then that there's an incredible resolution of information being shared here, we asked, how could we transform this noise of social media into an infrastructure that would support coordinated navigation of a water-infused city? And so instead of passively data mining, our team designed a software that engages with residents on social media to confirm flooding. How it works is when the software detects users using a keyword such as flood, our bots will send an auto reply introducing the project and asking if residents want to submit a flood report. If they respond, they are guided through 4 simple steps to submit a report, and this report is immediately plotted on a live map in real time. And this is what the map looks like during a period of flooding. And residents are actively checking the map to avoid flooded areas and organize for the safety of their families. And this is a method of crowdsourcing that allows us to reach millions of users every day, allowing us to pull information about community efforts, evacuation routes, and allows us to get flood heights in real time. We also work with government agencies who are monitoring the map to attend to resident needs, and they also share official information on the map. In this way, the platform provides a two-way information sharing system at an unprecedented scale for real-time coordination, which has not only improved coordination between formal and informal sectors of the city, but it has also increased response times and allowed for more efficient allocation of emergency resources. And it does this because instead of concentrating decision-making in a small handful of people, it uses the mobile phone as an urban interface where everyone in the city is able to participate in this infrastructure and disaster management. And so we see then that software cannot fix broken infrastructure, but it can help gap infrastructure failures. So when the hard infrastructures overflow, soft infrastructures can create a space to capture that overflow and render it useful for people to navigate the city. Instead of insisting on a separation of the water and the city then, the platform reframes new relationships between people, landscape, and ecologies, reintroducing a relationship to the river that reveals its entanglements on much larger spatial and temporal scales. And this opens up a space of a different way of understanding the water's flow through the city and of relating with the river. And so the project started in Jakarta, and we've expanded nationally and to other hazards as well, which is enabling us to think more thoroughly about devising relations for living and adapting together through several elements and ecologies in order to suggest different ways of cohabiting our environments that accepts our shared evolution with the biosphere. And so with that, I will pass it on to Nabi.
Yeah. Nabi, can I ask you, as you're going to be the host now, also to let the people who are in the waiting room to enter?
How do I do that?
If you go to participants,
okay,
and just admit them all in, so we have more people.
All right.
Together with us. Thank you so much, Nabi.
Yeah, no problem. Welcome everyone who is just joining us. Thank you, Nashin. Thank you, Lukasz, for having me. Let me just attempt to share my screen with you. Can you see my screen? Yeah, all right, great. Thank you. Well, I'm Nabi. I work at Shelka KB. I'm a urban resiliency specialist there. And I wanted to briefly kind of introduce our team. It's a big team of very young people who are tackling the issues of the urban environment in the 21st century. And when it comes to 21st century, we of course have to talk about climate change. And I think when we do talk about climate change, and what we now know already is that we sort of live in the age of uncertainty. And the approach that we took in the 19th or the 20th century, where we were so certain of the future that awaited us, and we build our infrastructure based on this one scenario of the future, is no longer applicable. We now know that we don't necessarily know what exact future is waiting for us, but we know that we need to be ready for almost any of them, all of them. So our solutions, or maybe not even, we don't even need to use the word solution, but our design has to be flexible. It has to be ready to kind of accept any type of challenges. So, and when it comes to climate change, what we see is that it manifests itself in forms of acute shocks like storm events, flooding that flood our cities, or acute chronic stresses that flood our streets every time there's a heavy rain, because the infrastructure that we built in the 19th, 20th century was not designed to handle this much rain, right? The precipitation that the engineers were designing in the past century has changed. This is the reality that is changing rapidly, and the infrastructure, because it's so final, the gray infrastructure that is so final and concrete, can no longer accept and adapt to this changing reality. So we need to rethink our approach, how we deal with water, and rather kind of to attempt to control it and get out of the city, get it out of the city as fast as possible. Maybe look at the water and let it tell us how it wants to behave, and kind of adapt to that. So in one of our projects that we did in the ARZAMAS, DIVEEVO, and SAROV cluster, we saw that the landscape played a crucial role in the religious culture of the cluster, and how it was tightly connected with the history of the space. So we know that the tools that we used in this project was remote sensing and the satellite imagery. And satellite imagery, of course, has its limitations, but at least it can give us some idea of what the landscape looks like and it gives us an opportunity to look at the landscape from different lenses, from different channels, to understand and see things that we might not normally see, right? Look at the landscape and see where it's fragmented, where we can actually reconnect it, and what are the issues it's hiding. Or in other words, like listen to the landscape and kind of let it help us design on the territory itself. So what we did here, for example, we looked at the vegetation index, and instead of kind of looking at the health of the vegetation, what we actually did, we looked at the dynamic of the vegetation of the crops. And what we identified here is that many of the agricultural fields around in the middle of the cluster were unutilized, so they were abandoned essentially, which kind of gave us an idea that they could be reforested. Another idea that satellites allow us to see is that around these agricultural fields, many of the streams and the creeks were originating, and every time it rained, it basically took all of this runoff from the polluted agricultural fields and polluted the rivers. And the rivers are within the Volga Basin, and the Volga Basin is notoriously the most polluted river in Russia. So we kind of took all of that approach, and we let the landscape kind of help us design itself, and then we restored riparian buffers on all of the streams to filter out the runoff, and also use those newly established ecological corridors as a site for an ecological trail. Another work that we do is a research on the flood resiliency in Russia. And then it might seem that the flooding is not as big of an issue in Russia because we don't have as much coastal cities as maybe some other countries do, but the precipitation is really the main reason of the floodings in Russia. And what we discovered is that more than half of the cities in Russia are actually facing some kind of threat of flooding. And then if you look at the past 20 years, the most devastating flood happened in TULUN, Irkutsk region. And on in the end of the June of 2019, 25 people lost their lives due to this flood event. And it happened because we still use this approach of one layer defense, right? There was a dam or a levee that was protecting the city. It burst because the climate has changed. It was not designed to handle this amount of water, and the city flooded. Another thing that kind of exacerbated the problem was the deforestation that happened in the water basin. And then what happens when you eliminate the landscape in the watershed? There's no longer trees, there's no longer roots that can actually hold the water, the amount of the precipitation, and making the flood downstream worse. And then here we can see that in red, all of the territory of the forest that was lost. So what we did, we analyzed how the water actually behaves, how it acted during the flood, and allowed that to kind of show us or kind of reimagine what the city could look like. So kind of allow us, let the water travel through the city, kind of let the water flood some of the territories, and use that space as a public space during a non-storm event, and during a storm event it can actually help to mitigate the flood. So this is not an actual vision that the city is going with. The city is building another levee, but this was just a concept, an idea that we wanted to get out into the public, and then we shared it with basically online by creating a platform. So some of these ideas originated when we worked at Nashin and the rest of our team. I'm switching presentations here. Could you see my second presentation? Yes. So yes, some of these ideas were already originating at Shulka Institute when we worked with Nashin and our other team. We were interested in the ideas of the territory and how we think about the territory. And the way we think about the territory usually is a static line on the map. But an interesting thing happens when the static line aligns with a dynamic system like a river, and the fluxes of the river ignore the line that we drew on the map, this imaginary line, right? And then our case study was the case of the Aral Sea and what happened in that basin, this ecological disaster on the, that was brought by short-term thinking, fragmented jurisdiction, and misaligned incentives. So essentially what happens is that this basin is divided by 5 countries, and every of the actor is acting in their own interest, and essentially taking water to irrigate their crops or cotton. And then in the end, it leads to an ecological disaster, ramifications of which that manifest themselves in the toxic desert storms. Because what happened was all of the agricultural chemicals that were used in agriculture were kind of sedimenting on the bottom of the lake. Now that there is no lake, all of the sediment is now a dust and potentially can be taken throughout this region by storms. And not only within this region, the wind can take this kind of polluted dust throughout other regions. And as far as Antarctica, we found animals with the lungs with particles of this dust within them. So what we see now here is that once we are making decisions that taking place in the water basin, the ramifications of those decisions will be felt by the players that were not involved in the decision making. So we were wondering if there's another approach to kind of managing resources that is based on not a political territory, but rather geological or ecological territory. And Nashin can maybe tell you more about that.
Yeah, so then we started looking at existing examples to see if there were other successful practices managing these sort of cross-border ecological systems. And if we return back to Indonesia, in this image here, the main river that drains through Jakarta actually flows through 3 cities. Slide. And although the formal flood policy measures only attend to those portions of the river that pass through Jakarta's administrative boundaries, resident networks have begun to self-organize around the river watershed. And so as the flooding got worse, residents living along the river devised this early warning system by creating an SMS chain that links all of the communities along the river watershed, including those from the other cities. And so this is a form of social organization that bases itself on ecological boundaries instead of administrative ones. And that was an example of emergent adaptive practice that forms around a water body. But then there are also more formally implemented ones that exist. In fact, Bali has one of the longest histories of a social governance model that's developed around the watershed. And this is because the topography of terraced rice fields create this condition where there's a need to coordinate water management between upstream and downstream fields, because if the water is withheld upstream, pests can infect the downstream fields, but then those pests can migrate upstream. And so because of this relationship, village boundaries are based on water basins in order to create social units of water management, which are then enforced by cultural practices that are modeled around the seasonalities of water. And so here is an example where the temporal immediacy of an ecological threat, which is the pest, prompts the alignment of social governance with ecological governance. Slide. And then on a larger scale in Europe, the Danube River is one of the most international river basins. And in 1994, 14 countries signed a contractual agreement agreeing to collectively manage the basin as a single hydrological unit rather than through divisive administrative boundaries. Slide. And then another example we drew from was bioregionalism. And this is a movement that proposes creating new countries where human activity is organized around both environmental and social features. And so pictured here is one of the most famous examples, which is Cascadia, which proposes combining states in the US and Canada. Now, the challenge is that they're not recognized as an independent entity, and so they don't have any jurisdictional sovereignty. And so we were looking at these and several other case studies where we saw that there are a lot of useful examples of transboundary water management that exist. Yet the challenge that most of them face is they often remain subordinate to the administrative jurisdictions. And so they're still fragmented under the current sovereign system. with their role being limited to coordinators, and thereby they face challenges in enforcement. And recognizing that there's this increasing gap between the interests of territorial boundaries and ecological systems, we were questioning how can current political systems adapt to climate change and respond to the ecological crisis. And so as a proposition, we're working on a speculative proposal of a new model of governance based on the logic of watersheds. And the project's titled MERA. And so if we move to the next slide, the MERA boundary is defined by the extent of a watershed, which incorporates territories and cities from distinct administrative borders under its jurisdiction. And it's the cities within this jurisdiction that form the MERA City Union in order to govern the new boundaries. And so by introducing this supra layer of territory and governance, one that's granted sovereignty through the city union, MERA aims to align political, economic, and social interests with ecological systems. And I'll pass it back to Nabi to explain how we investigated this through a case study of the Caspian Sea.
Yes, and our second case study was Caspian Sea, and what we noticed is that Caspian Sea, being the biggest lake in the world, is actually going through the similar events that led Aral Sea to its ecological downfall. So a brief history of the Caspian Sea. Before the collapse of the Soviet Union, it was divided by two countries, Iran and USSR. But with the collapse of the Soviet Union, 5 countries now shared its borders. And if you kind of recognize this body of water as a sea, then the surface and the seabed would be divided according to the length of the coastline. And if you divided this water body as a lake, its surface and the seabed would be equally divided between the bordering countries. So finally, Caspian Sea receives a special legal status that kind of combines both of these logics of the sea and the lake. Although geographically you can call it a lake, now politically we see that it has to kind of adopt a special legal status. We see how all the parties involved are trying to redefine what the water is essentially. And why is this happening? It's because this water body is rich with natural resources, like, for example, oil and gas. And we see that there is a high concentration of different companies that are extracting this oil and gas on the territory of this water body. And they are doing it according to the borders that are defined by the actors that are sharing the lake. So essentially, we see that there's a heavy pollution burden that is taking place here because of this extraction. And all of these kind of scenarios, all of these events are leading this body of water to on the same path that happened to the Aral Sea. And with the damification of the Volga River, with all the dams, we see that there's some of the water level is dropping within the lake. So perhaps we can expect some of the desert storms happening on the northern parts of the Caspian Sea. And we need to keep in mind that the whole of the Caspian Sea doesn't need to dry out or disappear for us to start feeling the ramifications of that, like we did in the Aral Sea. It's the size of California. It's a huge body of water that even if we lose a few percentage of that, we will feel the ramifications, and not only the countries that are dividing the area, but also all of the people who are living within the water basin itself, the Caspian Sea basin itself, and beyond. So we were applying the logic of the MERA, the ones that Nashin described, on the Caspian Sea water basin. So we were not only looking at it from as a design exercise or redefining the territory. We wanted to mirror itself. The word mirror itself means to measure a territory and an action that can be taken. So we saw MERAs as the rules or laws or policies that could be implemented in order to kind of make this idea reality. And what we also saw that the Caspian Mera is not just an ecological territory or anthropogenic territory. It's both. It becomes the hybrid. The infrastructure becomes part of it as well. So perhaps Nashin can add something as well.
Yeah, just to add a little bit to what Nabi already elaborated on, we were interested in both the definition of the territory as well as the implementation of how that territory would be governed. And that was the slide he showed where we developed a series of policies of how the city union would govern the territory in order to begin to transition away from an oil-based economy and to consider the health of the entire, all residents of this ecosystem, not just human citizens. And
Exactly.
maybe move on to the question and answer, unless...
Right, yeah. Thanks so much, both of you. This was quite fast. This was quite fast paced. I mean, of a lot of information about quite exciting projects. But I've also gave you instructions to all the participants in the chat window, and I will just repeat it now also as I'm speaking, because we're now entering the Q&A session, where you're encouraged to ask the questions in the form of the written questions in the chat. So just please make sure that when you pose the question, you start that question with capital letters question, so we know that it's really a question. And we're gonna, either me or some other people from the Viper Gallery will read your question. But before I give the floor to the questions from the other participants, perhaps I'd like to ask just a couple of basic questions to you, Nabi and Nashin, about exactly what's, this kind, especially when we're talking about Mera. I think it's quite nice to think about what's the proportion of the utopian thinking in this project, and what's the proportion of actual policymaking or actual proposals for policymaking in this project, because I understand that it departs from a certain tradition, which is actually a tradition of speculative architecture, perhaps, but it also goes in direction of showing us how we can use architecture as a tool of actual policymaking, perhaps. Can you elaborate a bit on that?
Well, I wanted to just to address the idea of the utopia here, and then the example that, for example, you brought up in the beginning of the NER, how this group of architects were designing a dynamic flows that were maybe sometimes imitating a flow of water, and rather than kind of looking at the already existing dynamics of the water itself, right, as a system, and designing within that reality. So, and we were actually avoiding the idea of the utopia or dystopian project. Here, we actually try to recognize the reality as much as possible and create and base our policies based on that reality. So the way we're designing our policies, that would the question can arise: why would any city join this this super layer? What is the reasoning for a city to join the union? And first of all, we looked at the process as a phase-based process. It was not kind of starting out all kind of all in. It was a step-by-step process. Right, and then we designed our policies specifically for different participants to join. So every city was joining for a different reason. For example, with Azerbaijan and Turkmenistan, there's essentially this race happening where both of the countries are trying to extract as much oil as possible because they're doing it from the same basin. They're extracting oil from the same basin. And depending on the infrastructure that they're using to extract that oil, the pollution on one side can be more than on the other one. So now, by inviting these cities into the union, there is no longer a need for this rat race, because essentially that the oil belongs to all of the union, right? And it's divided depending on their ecological performance. And again, like you said, Lukasz, it was a brief time to kind of introduce a very, very complex project that took us many months to design. And then I invite you all participants to go to the mera.zone, to our website, to see the full short film with the description, and perhaps we can also answer those questions as well. And Nashin, did you want to add something about the policies themselves?
No, I mean, I think that was great. Just to say that precisely as Nabi described, those policies stem from existing behaviors, and so that's like, this is something we were very interested in, is not just designing at the scale of the map and defining the territory, but interrogating this question from various perspectives. And so really understanding all of the actors at play there, including, the oil companies, but also the fishermen and the countries themselves and their various interests, and then modeling the policies around those interests in order to begin to incentivize certain forms of behavioral change. The video explains them a little bit more, but just to highlight the way this mechanism operates is that there are two, each MERA has two key features. One is the governing body, and then it also operates from this composite fund, which and that fund is comprised initially of taxes imposed on the various extractive activities, but also it then redistributes this fund, as Nabi said, to the different cities based on their environmental performance. And then there's a kickback to the countries. And so in this way, there's a consideration of why would cities join? Why would countries allow their cities to join? Why would oil companies become part of this?
All right, thanks so much for the answer. There's a couple of questions which are already stacking in our chat window. So I'd like perhaps talking about policies. I think I would like to also bring this question which was posed by Demetra, which is a question which goes like this. Thank you. This is a brilliant proposal on the policy scale. I was wondering if the project considers non-human relations on the micro scale and how those could possibly inform planning across scales, thinking of unnutzing and the Feral Atlas project being a useful tool for such thinking. Thank you, Demetra, for the question.
Nashin, you want to take this one?
Yeah, thank you. Definitely. We were looking at several scales, and as we mentioned, MERA, the governing policies of MERA are centered not around the health of the human citizen, but on all citizens, which includes non-human citizens. And so, for example, one of these policies that we defined was that all of the oil companies that were operating in the region had to enter an oil association in order to renew their licenses. But the renewal of the license is based on the water quality. And so, it's a collective, it's based on the water quality at a collective level. So for example, if the water quality falls below a certain threshold, all of the licenses are revoked. And this way, there's like a peer pressure sort of imposed between the oil companies. And this again, it tends to certain behavioral changes, but also uses the health at the molecular, the chemical, the biological level in order to determine a policy that would ensure the health of the larger ecology.
Yes, basically the oil companies were policing themselves, because if one is screwing up, then everyone gets punished, and the licenses are put on hold, essentially. Yeah, and then the way we control, we're proposing to control the water quality monitoring was, again, the remote sensing and in situ monitoring, which were constantly updated in life, and that was directly linked to the licensing. So when the quality of water exceeds an allowed kind of level, then the licenses automatically will be put on hold. That was one of the policies that we were introducing.
All right, there's another question by Diana, which was actually the first question which was posed in the chat. And she asks, how developed Blue Network in Russia is? I think this is mainly a question for Nabi. What work is going on in this field in Russia and around the world?
Well, perhaps we see a similar set of challenges that we can see in Europe or even in the States, where different jurisdictions, again, are making different rules or acting in their own interest within the same water basin. And we can see that even in the flooding that happened in TULUN, because when we actually talk about water basin, it's not just water, it's also the whole ecosystem, and the forest was part of that ecosystem. And by kind of deforesting areas within the water basin can have ramifications in a form of flood downstream. And then those decisions were made not by this city or the administrative entity downstream, but it was made by another one upstream. So we see this fragmented jurisdiction problem that is repeating, not only in Russia, but really in many countries. But we see that these other models of governing water bodies and then natural resources within water basins are possible. And I think, is it developed? It's probably not really, but what perhaps we could do is look at the examples that we bring in the project, like the Danube, or there was a Coral Sea Triangle, where we can actually create this super layer or kind of overlay another layer of jurisdiction where different administrative borders can come to or participate in decision making together based on the water basins they belong to or they are located within. For example, Baikal, Lake Baikal, the territory that is considered the protected territory of the Baikal, it doesn't cover the entirety of the water basin of the Baikal, Lake Baikal. So it's actually, but what we know is that anything that happens within the water basin will have an effect on the water body, right? So nearly half of the water basin in of Baikal actually lies within Mongolia. So we see that there are two administrative regions within Russia are dividing the Lake Baikal. It's the Irkutsk region and the forgot the name, but basically they're dividing the region, and although they're sharing the territory, and then the half of it of the basin itself is within Mongolia. So different regions have to actually come to different types of agreements based on the watershed logic. So yeah, we still have work to do.
Thank you, Nabi. Is there anything, Nashin, you want to add to Nabi's answer?
No, I think we can move to the next question.
All right, because there's a brilliant question by Martin Tarp, which actually goes in direction of some thinking about colonialism and infrastructures that we also plan to open a bit in our conversation. So Martin asks this question: both of these main examples, Jakarta and the Caspian-Aral Basin, are instances of two surprisingly, at least to my mind, similar historical processes. Hard fixed infrastructure imposed by European colonization, either Dutch or Russian, followed by extreme market nationalist conditions after the sudden collapse. My question is, as much as the ecological and technologically disintermediated ideas of resilience are vitally necessary and very often work against past legacies, how does this relate to current failures of political representation to provide necessary public infrastructure? And how could these techno-disintermediated forces you described work alongside state forces for both ecological and social survival?
It's an excellent question. Maybe I can start, and Nashin. We actually were discussing that in the preparation of this talk together with you, Lukasz, and Nashin. Is just the idea, our perception of water, and then the way we describe it. Right, we describe it as a static system. We ignore all of the dynamic processes that water comes through, and essentially we draw a static line on the map, ignoring all the fluxes, and this intermediate kind of territory that lies between water and land. And that's a colonial kind of way of thinking, right? Because once you draw that line, you essentially create an area to develop later on. Or so it's almost this kind of gerrymandering process happening, where you start creating this new real estate for yourself on the map, and then you act surprised when it gets so-called flooded. I recommend this to everyone. This book, Invention of Rivers, by Dilip Dekhonka, who talks about the idea that there is no such thing as a natural disaster. There's only a design disaster. We decide to describe this dynamic system as a static system, then develop the area on the shoreline, and then act surprised when it gets flooded, or we now call it a flood, right? So, and then another way we kind of exploit that line is that we start building our one-layered infrastructure on top of that, like a dam or a wall that would withstand water from entering the city. So we start really seeing an enemy in the water, rather seeing it as a resource or part of our kind of existence, really. And based on that logic, we design our cities, rather than thinking about what are the natural kind of, what are the natural ways the population was designing with water in these areas, what was their relationship with water, and maybe basing that, our design decisions on that. So,
I think also that even upon like the supposed or like physical withdrawal of these colonial forces from the countries, the relations still remain, the ideology certainly remain, because all of the approaches to flood management in Indonesia are about separating the water from the city through these huge technological projects, many of which are today related to Dutch consultancy firms and Dutch businesses. And so that hasn't gone away. The thinking hasn't gone away, neither have their relationships. And then if we look at like the way it's governed, right? Like it's the way territories are currently defined, it's a Westphalian mode of defining territories, and this also permeates imagination of how we govern our systems. And that's why, like in the example earlier, it's the flood management in Jakarta is only managed within the boundaries of Jakarta, which doesn't make sense if the watershed extends past that. And so it's because of these sort of dividing borders that there's a complete misalignment of interests of those bureaucratic appointments, which are also operating not only on scales that don't match the ecological systems, but on time scales that are completely dispergent. So like, because they're changing every 4 years, of course, it's short-term thinking that's governing any sort of flood implementation mechanisms. And so I think what we were trying to do was, well, if we approach this through an angle where we're redefining first the administrative boundaries so that there is some sort of alignment between the ecological interests and political ones, acknowledging, the behavior of both, that we can start to reconcile some of these gaps. But also in terms of the short-term thinking, I think that's another thing like we spent a lot of time thinking about, because no matter how much we know about climate change, it seems that we can't seem to move past this limitation of we're only able to conceive of certain timescales, which is why I think in our conversations and in the policies we were describing, we're like, okay, well, how can we then inherently embed the interest of much longer futures and tie that in to have sort of an immediate feedback, sort of like expanding on the Bali case study where it was the immediate threat of the past that necessitated the alignment of social and social governance with the ecological governance. How could we do that on a larger scale?
Well, both of your answers immediately made me think about Paul Virilio and his thesis that invention of a new technology is also invention of the accident that is somehow inherently related with that technology. But both you basically said that, I mean, something similar, but that disasters are designed, or that infrastructures or the natural disasters are actually infrastructural disasters. So I'm just thinking about like how we can creatively work with this thesis, like to perhaps invent a bit different modality of our practice, which would be based to be on the fact that we should be aware of these disasters, which are always, or these accidents, which are always linked to the things we create, and how to creatively, I mean, think about preventing them, or creating a space of multiple possibilities which we work, which was also, I think, the thesis that Nabi was, and you, Nashin, as well, you both were kind of tending towards this kind of idea of designing with multiple features, perhaps, in mind.
You know, when in our design process, we had many different ideas that we were investigating, and maybe some of them didn't make the final cut. But I think one of the ideas that was not mentioned in the final movie, but was interesting, at least to me, was the idea that, like Nashin was talking about, the danger of the pest that can be kind of perceived by a person, and because it's a short term in this problem, right? How do you short term in the scale of, you know, so how do you then visualize a problem like RLC that took decades for people to fill, right? So there was an idea that going back to this, the water quality monitoring, or the in situ monitoring, or the remote sensing monitoring, all of this data would essentially be kind of processed, and the projections would be made based on this data into the future. So seeing if this basically, if the things will keep going, keep happening in the specific way, what are the projected futures? And then the rules were made based on those projections. So if there is pollution happening, there's a projection happening that in 10 years, 20 years, this is the landscape that we will have here. So we need to make our rules based on that. And it would be constantly changing. So we were playing with this idea of a dynamic constitution for this area, right? So just like the systems are dynamic here, can the rules or set of rules can also be dynamic and be changing based on the constantly kind of monitored data. That was just one of the ideas that we were playing around, and I think maybe in another project that is worth exploring further.
Yeah, and just to mention another resource that thinking sort of heavily drew from was Suhail Malik's the speculative time complex, where, you know, it's thinking it's thinking across multiple possibilities and design and in this way designing systems for multi-stability instead of, you know, just one like single-handed approaches limited to like a single solution. This is sort of constantly adapting and responding to various ways things could change, not only from one perspective, but from various perspectives as well.
It made me think about that even with Suhail in Moscow when he was drawing those diagrams the whole morning with all those possibilities of how we can think about the future. That is really amazing. Just to explain everyone, we know Nashin and Nabi, we know each other from Moscow, from Strelka Institute, where we actually met in 2019, 19 it was, right? The last year of the new normal.
That was 18, no?
18, I think so. Yeah. The sense of time in these pandemic times is a bit rigged in a way.
Mm-hmm.
Nevertheless, do we have any other questions from the participants? I've also shared the couple of references that Nabi and Nashin mentioned during their answers. The book by Dilip Da Kuna. Dilip Da Kuna, is that the way how to pronounce that?
Kunha. Yeah.
Kunha. And also the edited volume by Suhail Malik and Armen Avenassi and the Speculative Time Complex. So also you can have a look into the resources and the references that our guests use in developing their practice. I guess since it's 11 a.m. at least here in Czech Republic, we can also call it the end of the meeting today, of the second session or the second even from the Architecture of Nature series. Or do you have anything else you want to add to what you said so far, Nabi and Nashin? If not, okay. I'm not good in ending Zoom meetings, but let's end this one here. Thanks to everyone who joined us. Thanks to all the participants. Thanks to Nabi. Thanks to Nashin. You can give them a clap, at least in your room. And I also clap. And hopefully we're going to see each other at the next Architectures of Nature series, which is going to happen at the beginning of December, most probably. But we will update this in the due course. And the guest will be Elise Hunchuk, who's going to talk about her practice, which is related to another element of natural architecture, the air or the atmosphere. So thanks so much and have a nice rest of the day. Bye.
Bye.
Thank you. Bye.
Thank you.